Section 8.5 Exponential and Log Equations. Objective number 1, we will solve for the log equations. We will have two cases. The case number 1 saying that if you have log base a in both sides and the m and the n are the argument, then they must be equal each other. In case number 2, you have log in one side, log base a of x, and you have one side is a number. Then we use the definition a to the power of b equal to x. The way to recognize is going to be in case 1 or case 2, we look at the equation. In the equation, if you have a number, no log but just a number, that would be case number 2. And case number 1, when you have all of them are log, okay? Like example number 1, you see you have log on the one side and log on the other side. Look like case number 1 we will use for example 1. We need to get rid of this 2, and you recall that we can move this 2 up. We use the power rule. Then log base 3 of x squared equal log base 3 of 25. The m will be x squared and the n is 25. Then the m and the n equal each other. Then x equal plus minus 5. Now we check. If we put in x equal to 5, then 2 log base 3 of 5 equal log base 3 of 25. You will use the calculator for this, okay? How do we calculate this? We can use the change base formula we learned in section 8.4, the very last topic, and you can see that they will be equal. And we will check x equal to negative 5. Then 2 log base 3 of negative 5 equal log base 3 of 25. The argument in this case is negative 5. Now we recall the domain of the log. The domain of the log is that domain of the log is from 0 to infinity. That means log of x, right? So the x is the argument. Then the x must be greater than 0. So in our problem, the 5 is the argument and the 5 is not in the interval from 0 to infinity, so it does not work. And if you use the calculator, use the change base formula and use negative 5, it won't work, okay? Let's recall for you how to calculate this using the change base formula. We can either use log 25, log base 10 over log base 3, okay? In this case, we can use log or ln, right? ln negative 5 and ln 3 and multiply the 2 in the front. But when you calculate the ln of negative 5, you will get error in the calculator. Example number 2, we see that we have a 3, a number that will be in case number 2. We need to combine the 2 log on the left hand side. We use the product rule. We will multiply them. And then we can use the definition 2 to the power 3. So x minus 2 times x equal 2 to the third power. We distribute, open the parentheses, and we will move everything on one side and solve by factor. So the two number we get is 2 and 4, negative 4 plus 2. Then you will set 1 by 1 equal to 0 and solve. We will get x equal to 4 and x equal to negative 2. Now we log back into the equation and check. So we check x equal to 4 first. We will get log. For the first parenthesis, we got 4 minus 2 And 4 minus 2 is 2 plus log of 4 equal to 3. I'm looking at the original log equation and log x equal to 4. So the first one, log base argument 2 and the base 2, using the property or by definition, you can see that 2 to the 1, the answer have to be 1, is equal to 2 in the argument, plus 2 to the second power. That's why you see the number is 4. And this is the true statement. Now we check x equal negative 2. Log base 2, you got negative 2 into the parentheses, you will get negative 4 plus log of 2 of negative 2 equal to 3. The argument of this log is negative 4 and negative 2, and we record the domain is have to be, the x have to be greater than 0. The argument must be greater than 0. So it does not work. You have to eliminate the negative 2. The answer for this problem is only x equal to 4. And for the other problem, number 1, the answer is x equal to 5.